Alright, so in this video, I want to take you through the concept of LangGraph. So this LangGraph is a newly added component to this LangChain ecosystem. So if you are following this YouTube channel, you have seen that I have a playlist of LangChain crash course where we discuss different components of LangChain, where we have like model input, output, chains, memory, and retrieval, right? And agent also we have discussed previously in this playlist series, where we use the other components like the chains, memory, retrieval, and then we kind of plug in those as a tool to the agent, and agent kind of the LLM kind of acts as a reasoning tool to determine which tool to choose, pick and choose, and then perform certain actions, right? But with this new concept of LangGraph, we to create more highly customizable and flexible agents, right? Where you kind of design the flow diagram and the flow engineering with according to your requirement, and how you can design this whole flow is totally up to you. So the more flexibility and customization options are much more greater if you are using LangGraph to create certain agents. Right. So in this video, I will take you through the basic concept of LangGraph, how you can use different basic building blocks of LangGraph to create so something which looks like this, where the user comes with a query, then that query goes through a LLM call, which will kind of classify the user query based on certain topics, which are like the topics can be Japan, sports, or not related, right? And then we will have a conditional edge, where that conditional edge will act as a router to route that question to either a RAG based retrieval, or it will pass it through LLM call to get the answer. And then we kind of get the final answer to the user query, right? So with this, we will start this. So we will not start with this very complex looking diagram. So we will start with very basics, and then slowly we will build upon and build this final component for this video, which is kind of a based on the user query. It will either do a RAG call or LLM call to get the answer, right? So generally, like the first you need to install this, like which is pip install LangGraph, which will not part of the LangChain installation. You need to install it separately. So once you done the installation, then you can start building graphs on top of this framework, right? So the few of the concepts which are related to LangGraph. So generally, as you can see, the name itself has a graph component to it, right? So generally, we will build a graph using this LangGraph, and then we will kind of design the whole flow engineering, and then we will kind of build a solution on top of that. So few of the terminologies, like generally we have several nodes. So you can see, like for this example, we have a node 1 and node 2, and these nodes are connected by edges, right? So user kind of pass a query to this node. So this node 1 will be kind of the starting point, and node 2 for this example is kind of the end point of this whole graph, right? Now, this node can be replaced by any user-defined functions, right? So you can easily replace this node to user-defined functions, or it can also be called to a tool, a call to LLM. So that is totally up to you how you design this whole architecture based on your requirement, right? So we'll start with a very basic example where we have two functions. So one is like function one, where the input comes, and then we attach a string to that. So that is like, this is the string which we are attaching to the input that is coming to this node. And then we also have function 2, and there also we are attaching to a certain string. So it's kind of a basic string concatenation which we are doing inside these two functions, right? So once the functions are defined, then you can add this function as a node to this whole graph. So first of all, like you need to import this graph component, which is like from LangGraph.graph, you import the graph. Then you kind of define this, initialize this graph, where you are naming it as workflow. And once the workflow is defined, then you can start adding the nodes, right? So you can see like the first function I have added, and I'm naming this as node 1, right? Then the second function is being added, and we are naming it as node 2. Then we will kind of draw an edge between these two. So this is like the starting point of this edge, and this is the ending point of that edge, right? So you can see like this is where you are kind of establishing the relationship between the function 1 and function 2. So what will happen is the user will pass a certain input. That input will goes through the function 1, and function 1 will do some sort of string concatenation. Then that output will be passed to the function 2, and function 2 again will do a string concatenation, and then it will generate the final output, right? So once this node and edge are defined, then you need to set what is your entry point for the graph, which is like node 1 is the entry point, and also what is the finish point for your graph. So once you kind of define all these things, the nodes, the edges, the starting point and the finishing point, then you kind of compile this and create an app out of it, right? So after that, you can start passing the user input to this graph, right? So how you can do is, so this LangGraph kind of uses the LCEL, which is a LangChain expression language. So you can straight away do this app.invoke and pass your input. And then you will see like you will get the final output once we call this. So you can see like, so my input was like I am moving from, and then it kind of attached the first function's string, which is like I am moving from function, first function, and then the second node kind of receives this input, and then it attaches the further string that is present in the function 2, and then it kind of generates this full output, which is generated by using a LangGraph, right? So this is kind of a very basic example. Now, if you want to break it down and see what are the things that are happening at each node, so that you can do like you can stream this output, and then once you stream that input, and then we kind of get an output, and using this output dot items, you will get the key and value. So key is nothing but the name of the node, and the value is the output of that node, right? So if I run this, you can see like this is the output from node 1. So the output of node 1 is like I am moving from first function, then it kind of goes to the node 2 or the second function, and then it kind of concatenates the second function string also to it, right? And then we kind of get the final output, which is like I am moving from first function to second function, right? So this is kind of a very basic thing which you can which will help you to kind of build the concept and how the LangGraph is actually working, right? So then what we are doing is we will integrate a LLM call to this LangGraph. So for that, what I am doing is, as I have also done for my previous videos, I have importing the LLM as a together API call. So that using that together API, we are passing the model. So we are passing this Mistral 7B. So we are kind of using this chat OpenAI function, but we are kind of passing the Mistral model as kind of the LLM to this. So this we will further use in the second video, where we will integrate some sort of tools, and then we will kind of build a graph and do the tool calling or the function calling in a much more advanced way, right? So once that is done, so then I am just testing this LLM. So where I am passing this high as an input and getting the output. So that output can be accessed by this dot content variable, and then you can get the output of that, right? So then what we will do is, this is the second part where we are kind of increasing the complexity of this LangGraph, where the user input will come. Then that user input will go through a LLM call. So that LLM call we are calling as agent. Then what we are doing is we are kind of passing that input to the second function, where it will kind of change the input that it has received. So as we are not making any LLM call, so generally we are calling it as tool, right? So here we can see like the two functions again I have defined. Here I have written a complete query where I have written a prompt that based on the user input, you need to do a topic identification, where the topic has to be either Japan or sports, that based on the user input, right? So once that is done, so we will use this LLM.invoke to do LLM call on this complete query, and we will get the response, and we will return the response.content from this function 1. So this function 2 will kind of receive this response.content, and then it will just do a simple string manipulation again. So it will just do the uppercase of that topic, and it will return that output from this final node, right? So similarly, we are again like adding the nodes, where the first one is the function 1, where I'm naming it as agent, and the second function I'm naming it as tool. Then we are kind of adding a age and also setting the entry point and the finish point. After that, just that I'm passing a user query, which is like, tell me about Japan's industrial growth, right? So you can see like based on this input. So finally, the output that we are getting is this, right? Here is the topic in uppercase. So the topic was like Japan, and in bracket it was like industrial growth, and which is coming as in a capital letters, right? Now, if you break down this steps, so you can see like first the topic is coming as Japan, then there are like few extra text which are coming up, and then it's kind of doing again it's passing the input to the second function call, and then it's kind of converting whole string to a upper case, right? So this is how we are just integrating a LLM call to this LangGraph, and we are kind of building the more complex graphs, right? Now what we will do is we will integrate a RAG pipeline to this LangGraph. So like we are building a RAG that I have been using in my past few videos also, like in the source folder, we have 2 text files, which are, one of them is related to Japan, and another is related to a sports news. Then we are creating a retriever out of this using this whole RAG pipeline, and we are kind of using ChromaDB as a vector DB, and then we are creating a retriever out of it. So once that is defined, what we are doing is we are just testing the retriever. So we are passing the same query again, tell me about Japan's industrial growth, and we can see that the original text that has been retrieved using this retriever. So we can see the page content and the text that is present using this retriever method, right? And after that, this is the integration of RAG along with the LLM call that we want to build using LangGraph. So first the user query will come, that will pass through LLM call, and then that output will go through a RAG call. So that RAG call will kind of do a retriever, and then it will generate the output, right? But the problem here is that when we are doing a RAG-based retrieval, we want to pass the user question also along with the context that is being retrieved from the RAG. But as you can see here, we are passing the user query to the function 1. So function 1 kind of generates output, which will be passed to the this next function, right? So we do not have access to the user query. Now, to make this user query available, what we will introduce here is we will introduce a concept of agent state. So this state is kind of accessible to all the nodes, and using this agent state, you can kind of add the new messages to this state, which can be also accessed using the further nodes that are available in this LangGraph, right? So you can see I have added a new concept of agent state, where the user query is being sent at first to the agent state, and then we are making the LLM call, and then whatever the output that we are getting using this LLM call, that we are also appending to this agent state. Now, if you want to do a retriever, and then we want to pass the original question along with the vector DB, which will act as fetching the context, so that we will the user question using this agent state, right? So using this agent state, we will fetch the question, and then we will do a RAG retrieval, and then we will kind of generate the final output, right? So you can see I'm creating a dictionary, which I'm naming it as agent state, and there we are kind of creating a blank list, where I am mentioning that the agent state message is equals to a blank list, right? So this is the agent state, how it is looking like. So after that, like few of the functions that I have written here. So first, using this state, which is nothing but the state that we will pass through this graph, which is nothing but the agent state. So there, the first message will be act as a user question, right? So once we pass that, we will get the user message using this, and by fetching the last element of this message, we will get the question, right? Because at this step, this would be the function one would be the first node, and the message that we will receive, that will only contain the user question, right? So using this, we can access the last element of the list, which will kind of give us back the user question. Then we are attaching this user question, and we are asking it. We are creating a prompt where we are trying to do a topic analysis, and we are asking it to either classify using this Japan or sports based on the user question. Then we are kind of doing a LLM invoke where we are passing this prompt, and in the end we are appending this response.content to this state, which is kind of available to the other nodes also, right? So, and in the end we are returning this state from the function 1. So similarly for the function 2, so using this function 2, what we are doing is we are fetching the first element of the message, because that will correspond to the user question, right? So once we get that question, that we can pass it through this prompt template, which is kind of a regular prompt template, where we are saying that answer the question based on the following context, right? So here the context will be retrieved from the vector DB, and the user questions we are getting fetching from this state variable, right, which is available to all the nodes of this LangGraph, right? So then we are doing a regular retrieval chain, and then we are passing the question when we are invoking this retrieval chain, right? And we will getting the final output, right? So this is where we are again creating a LangGraph, where we are mentioning the first function as agent and the second function as tool, and then we are creating the graph, and in the end we are passing this question. So one thing to be mindful here is we need to pass this as a dictionary where messages equals to this list value, where in this list you will pass the user question. So that is like, tell me about Japan's industrial growth. Then we are kind of doing app.invoke and passing the input. So this input will be a dictionary where the first element would be the user question, right? So we are getting this output, and which is nothing but the RAG retrieval output, right? So similarly, we can ask another question which is of the category of sports, and then we are getting this output, which is again doing a RAG retrieval and giving us back the output. Okay, so now if we break down each of these steps and want to see like what is happening in each of these nodes, what we can do is we can do this app.stream where we are passing the inputs and we are getting the output after that. And using this output, we can access the key and values, which are nothing but the node names and what is the node output, right? So we can see like for the first node, which is we are also calling as agent, we are passing this question to this, and we are getting the output, which is nothing but a topic classification output, which will tell us that the topic is sports, right? And then in the second function call, or the second node, which we are mentioning as tool, there we are kind of getting this output, which is kind of a RAG output. So based on the user question, it is kind of doing a retrieval and it's providing you the output for that particular question, right? Now, to simplify all this, now we have seen that like to maintain this agent state, what we are doing is we are passing a state variable, then we are fetching this value, and also we need to append intermediate outputs from the node if you want to access that for the further nodes. To simplify this process, what we can do is we can create an agent state, and using this annotated method, and then we can annotate that this will also we can add certain values to this messages, and we can also have the base message which we will pass through across this agent state, right? So this will kind of, if we use this class and we pass this class to each of these nodes, and then the agent states can easily flow across different nodes and different edges, and we don't need to manually add the values to this agent state, right? So but that will enabled by this operator .add, which will the agent output will be automatically added to this agent state, right? So now in the final final part of this tutorial, what we will do is we will kind of build this complex graph where the user will come up with a question. So that question based on that question, we will do a LLM call, which will do a topic classification, and it will classify on these 3 topics only, like Japan, sports, and not related. So if the topics are related to Japan and sports, then we will use this conditional edge, which will also act as a router. So if the topic is related to Japan and sports, then it will do a RAG-based call, and it will retrieve the output based on the user question in this path. And if the topic is neither of Japan or sports and it is not related as a topic, then what it will do is it will do a LLM call to generate the answer for the user question, right? So it is kind of a conditional edge where, based on the topic that has been identified in the previous node or the first node, it will route the question in the particular direction. Then we will have an end node which will kind of signify what is the end state of this whole graph, right? So what we are doing is we are creating a pydantic parser. So as you can see in the previous steps, the topic was not getting properly parsed. So that's why I kind of used a pydantic parser, which will ensure that the topic is selected in a proper way. So which will be either Japan, sports, or not related, right? So here we kind of added those parser and the prompt. Then we are creating a chain where we are passing the prompt, the LLM, and also the parser, which is nothing but a pydantic output parser. Then we are doing this chain.invoke inside this function 1. And you can also see that I am passing the state here also, right? And as we are returning the topic from this output, so we need to return in this key, in this dictionary format, where the key would be messages, and the response.topic, which is kind of the output of the pydantic parser, that will be the value of this dictionary, right? So then we are creating another function, which is function 2, where we will do the retrieval based on the user question. So you can see, like, we can, using this state, we will retrieve the question, which is like the first element of this message list, and then we will pass that question to the retrieval chain, where we also have the context that will be retrieved using this retriever, and then we will return this result, right? So another thing to be keep in mind, that we also need to pass this as list. Otherwise, this state function will not work, right? Based on the definition that we have created previously. And in the end, we have created another function, which is a function 3, which will simply do a LLM call. So whenever the topic is not related, then it will do a LLM call, which will retrieve the answer based on the question, right? So then we are creating a router. This router will access the message's last element, which will be the output from this function 1. So this we will see, like, how we kind of define this flow, then that will be clear. But this function 1 output will be captured by this router, and then it will check, like, if there is a text that is present in this last message, which is the message's last element, and then if there is any text which are related to Japan or sports, then it will return this value, which is RAG call. And if that is not the case, then it will return a string, which is LLM call, right? So after that, like, we will add all these nodes to the graph, which is like function 1, function 2, and function 3. And this naming convention, or the names that we are mentioning here, that is very important, because that we will use in the conditional edges, right? So the first function, where we are doing the topic classification, that we are naming as agent. Then we have a RAG, which is the function 2, where we are doing a RAG based retrieval at generating the output. And the third one is we are simply doing an LLM call, which we are naming as LLM, right? So then we are setting the entry point as agent, which will act as an entry point of this graph. So at the entry point, it will do the topic classification. And then what we are doing is we are adding a conditional edge, where we are mentioning that the start key is agent. So that will kind of ensure that the this agent output will come as an input to this conditional edge. And then we are mentioning that the condition is defined in this function, which is router. And then we are mentioning what is the conditional edge mapping, right? So if the text that is being outputted from this router is rag call, then we will call this rag load, which will be same as this function2 name. And if it is related to LLM call, the text is LLM call, then we will map it to a LLM, which is a function3, right? So this name should match for the function2's name and the function3's name. Otherwise, this conditional edge condition will not work, right? So once we added that conditional edge, then we will add the other edges where we are kind of creating an edge from rag to the end, and we are also creating a edge from LLM to the end. So in that way, we will kind of create this graph, right? So I hope you got an understanding of how this graph is getting created with the help of conditional edge. So based on the conditional edge, it will either do a rag call or a LLM call. And in the end, it will end in this part, right? So once all this graph creation is done, then we can like compile this and create an app out of it, and then we can pass this input, right? So first of all, I am passing this question, tell me about Japan's industrial growth. So you can see that first it's calling the agent, then it's returning this topic, which is nothing but Japan, that the topic that has been extracted using LLM call. And then it is going to the router where it is seeing that the topic is related to Japan. So it's calling a RAG-based retrieval, right? So that we are getting this in this output. So in this output, you can see like the if you access the message key, you can see that all the intermediate steps are available. So first it's the question that is being present in this state or this output variable, then the topic, and then the RAG output that we are getting. So we can access the RAG output using this, using the last element of this message, which is by using -1, we can get the final output of this whole LangGraph, right? So then we are passing another question, which are again related to sports category. So you can see like it's correctly classifying the topic as sports. Then it's calling the RAG and it's doing a RAG-based retrieval, right? So then I am asking a generic question, which is neither of the category of Japan or sports. So I'm asking a question that tell me about BERT model. So then we can see like these are the flow. It's calling the agent first, then the topic is coming as not related. So the router is kind of choosing the path of calling the LLM to get the answer of this question. And you can see this is how the final output that we are getting using this LLM call, right? Which is kind of a LLM based call, and then with LLM with its own knowledge, it's giving you the output, right? So I hope you got an understanding of how we can build a fully customizable and how we can engineer this whole flow of this LangGraph, where we have a lot of power to create agents. And in the next video, what I will do is I will add few of the tools and how we can do a function calling using these tools